My first guest today is Kromer, founder and CTO of Infochimps, and he's here to talk to us a little bit about powerful black boxes with beautiful glue and best practices that you might be able to ignore. Flip, thanks for being with us.
Thanks for having me.
So that first phrase, powerful black boxes with beautiful glue, what does that mean?
So we kind of, there's there's DevOps, right?
Yeah.
Where you have you could almost call this ops dev, right? Where you're programming. Sure, you're writing programs, but what you're really doing is stacking together Lego pieces of industrial tested components and using things written in a high-level language to prototype them fast, find out what actually needs you to be clever or smart, but get it out there. So as an example, we have a kind of distributed robot army guided scraper, and it's capable of 1 billion object inserts a day. And the way it works is you have a res queue, which is nice, well-tested, insulated component, and we just install it, and it's something that just says, hey, here's a thing to scrape, Twitter followers for this ID, page 3. Then there's a little Ruby script, very stupid, never fails. It only has the following responsibilities. Pull in a job, fetch the appropriate URL, ditch the answer to disk. That's it. Now, once it's on disk, it's picked up by Flume. Flume is it was written and is typically being adopted to do log aggregation. But in reality, what it is reliability glue. It picks up the data, and at that point, that data is in the hands of God. Like, it will get to where it's got to go. You put in a midstream decorator that takes the raw response and parses it into database objects. You can test that thing at the command line, standard in and standard out, and then drop it exactly the same script into the cloud, into Flume. Finally, there's a sink, again, nice little Ruby shim, that just takes the output and distributes it to the appropriate database. These into HBase, these tables, these into Elasticsearch, right? So that whole thing, it wasn't so much a matter of writing a program, it was a matter of assembling programs into a cluster, and that's so it's like molecular level programming. And really you just think about stacking these together, and with things like Chef, your ops burden of doing so becomes dramatically lower.
So you mentioned Chef, you mentioned Flume. What are the advantages of using those?
Basically, the more you can decouple your systems, the better you can scale. Now, your decoupling first comes from having hard, rigid interfaces between things, right? Where you're saying look, it's really easy to understand. I'm writing things to disk separated by new lines. And that's the contract for the, scraper part of it, right? So build hard interfaces, and wherever possible, decouple. The landing stuff to disk, it's really hard for anything upstream of that to, those can now fail pretty independently and maintain robust. Chef and Flume are, you have this traditional toolkit, your distributed messaging queue, disk, all the, putting HTTP shims in place of things. All these things are ways to kind of separate out a hard, but really anything can access it interface. If you look at how a lot of people use distributed messaging queues, it's there's a lot of cases where it's I'm putting in heavyweight objects at a really rapid rate, and it's putting a lot of load on the thing. And up till now, it's been the best solution. But everybody knows it's not the right solution. What you really want is, hey, distributed messaging queue, that's your latency case. Until now, there's never been a throughput case. And that's Flume. And the flexibility, the elegance of it, it's just we have these sources, we have these sinks, and we have these adapters, and if you don't like one of them, just change that, and the rest of it just glues together, data goes where it's supposed to go. With Chef, it enables a whole host of things that you couldn't do before, but let's say one of them, on the point of decoupling, is you'd traditionally have a centralized data store, and you'd really trying to make everything kind of, be built off that, because the database was hard to maintain. In fact, there's a name for the people that do nothing but administer them, right? Yeah. With Chef, it's hey, you know what? This res queue needs a queue, is backed by a Redis database. Give it its own Redis database. This thing over here needs Redis to do rate counting. Give it its own Redis. This thing over here needs one. The worst thing you could do would be to point those to the same database, because now those are strong coupled, like big arc all the way across the system diagram. That's terrible. Whereas installing put this line into that recipe, Redis is installed. That's cheap now, it's free now.
Are there certain operations best practices that can be ignored?
Yeah.
It sounds like a loaded question.
It is. Well, it unlocks a whole bunch of things. The number one thing, and I mean, this is just amazing, this process of having strictly defined interfaces, small inspectable components that you can understand in their totality, and I'll include things like, Cassandra and HBase. Those are obviously internally super hairy and complex, but at their external interface, it's like, here's some data, hold on to it according to certain guarantees you give me, and I'm going to get it back later, right? At that level, they're all simple and the same. Since you're decoupling the system around strong interfaces, no more meetings, no scrums, screw scrum, right? Like screw agile, all this. If I see like 4 engineers standing around talking about something, like it had better be like sports or where they're going this weekend or something like that. Because like otherwise I want to know what got fouled up on my system diagram that I let this terrible situation where a meeting happened occur. Like, if your scripts are only this big, you don't have to branch, you don't have check-in collisions, it fits in somebody's brain. These pieces of glue I talked about, like that scrape architecture, if that sounds like the kind of thing that a sophomore CS major with 2 months of experience on the job could write, it is. He actually not only wrote but architected that whole thing, right? It's because you have clear, well-defined things that you can fill in, so it lets you be really efficient with your labor. So anyway, the main one is the meetings thing. Oh, integration tests only. You don't have to go around testing the insides of things because honestly, there's no insides of things to test, and you shouldn't be doing that anyway. So.
Interesting. Do you have a sense of how cloud architecture is going to influence the operations world in the short term, over the next 2 years or so?
So there's a bunch of things you can do now that would be just unimaginable before. Let me give you 3. So one of them, this is great because it still makes people's hair stand on end. The data stores that we have in production at Infochimps, we have HBase, Elasticsearch, MySQL, MongoDB, Redis, SimpleDB, S3, I'm leaving off 2 others, but it's a long list, right? Because look, if I said, hey, let me tell you about all the apt resources that we have on our machine, you'd be like, why are you wasting my time telling me that you have like those plugged in, right? If I told you I built a Rails site and I use 9 plugins, okay, right? This thing used to be expensive, called maintaining and configuring a machine. Now it's find the publicly vetted recipe for doing it, drop it in, boom, it's installed. So when we have some Hadoop jobs where we'll have to, for instance, do a parse of a bunch of scrape data, CPU intensive, and then do a bunch of graph manipulations on it, very, very memory intensive. We'll spin up a cluster of C1XLs of like, 8 core, very CPU heavy nodes. So 20 machines will do the job on that. Ditch the data S3, bring that cluster down, and bring up a different cluster sized for this job of 7. It might be like, then 60 34 gigabyte machines or something like this if it's a big hairy billion edge graph, and run it on that. Right? You can't do that with physical hardware. Is to say, hey, machines, reconfigure yourselves, right? We upgraded recently from HBase, whatever was before that, to HBase 09. So all we did was we took our cluster and we spun up a new cluster, populated our data into that, took all the production servers, pointed them at the new database, found out it was running great, but if we wanted to, we could just bring the symlink back. That's a really common pattern in deploying a website, right? You put it into a directory, shift a symlink. Now you can do it at the molecular level of the cluster.
Interesting. So last question for you, and this is based on something we were chatting about off camera before, but you had said that a previous New Year's resolution of yours was to think small. What does that entail? Right.
Well, that was about so look, I'm an academic by background. I was a physicist. And you know, you're like, there's this great thing we can build and it's going to be awesome and it's going to need all these things. And, you know, code has a carrying cost, right? Code is inventory. Code costs you money. And I don't mean writing the code. I mean having the code. Having to say, oh, if we do this, it's going to break that, right? And also, what you need to be doing is shipping. Startup is a device for turning time and money into validated assumptions about what the world wants. So you need to be identifying exactly and only your immediate realm of ignorance and attacking that. And so that means, yeah, keep your eye on the big prize. Make sure that your ship is always able to kind of tack to that goal. But really kind of think small. Let yourself write crappy code. Let yourself get something out that's deployed that, you know, you let the world decide whether they're actually going to hit it at a rate of 1,000 times a second, then address it. So,
Well, thanks so much for being with us.
thanks
Really
for having me.
appreciate it.
Really appreciate it.